Okay. Today is 4.4, the mean value theorem. So what is mean value theorem? So we discuss uh, one by one in this lecture. Let's start it with 4.41, which is uh, Rolle's theorem, then mean value theorem, and then three important consequences of mean value theorems. Let's start it one by one. So what is Rolle's theorem? This theorem says that if the output of a differential function are equal at endpoints of an interval, then there must be an interior point, which point is C, where derivative of that point, that is derivative of C equals to 0. This is that अगर हमारे पास output of differential functions are equal at endpoints, let us say that output means that there's a starting point. This is the starting point, and the second point is this endpoint. Okay, so here the value is 2. Let us say the value is 2. Again, this is starting point and this is ending point. My curve is like this one. Okay, so this means that the outputs of differential functions, this one, the starting and ending points are equal. So sorry. So यहाँ पे मेरा थ्योरम ये कहता है कि देयर मस्ट बी एन इंटीरियर पॉइंट C, so that there is an interior point between which acts in this interval, where the derivative of that point must be equals to 0. Okay. Again, रिवाइज करता हूँ मेरा इस थ्योरम. ये कहता है कि अगर output of a differential functions, let's say this is the starting point, this is the ending point, are equal. So this means that they have the same value. So अगर हम एक पॉइंट उसी इंटरवल के दरमियान कोई पॉइंट लेते हैं, लेट अस से यहाँ पे मैंने पॉइंट ले लिया C, तो उसका डेरिवेटिव मैं लूंगा तो दिस मस्ट बी इक्वल्स टू 0. So this is the Rolle's theorem. So Rolle's theorem basically applies at endpoints, and where my interior point, let us see it is C, so the derivative of that point must be equals to 0. So this is again, let f be a continuous function over the closed interval. Closed interval may be this point. Let us say this is A and B. Okay, starting point and ending point. And differential over the open interval such that function of A, this means that the value of function of A equals to value of function of B. So there exists at least C, where C is the member of AB, that C lies within this range. So derivative at that point must be equals to 0. Okay, तो मेरा function मेरी curve ऐसी भी हो सकती है. Now in second case, this will be like this one, that it is starting point is this, ending point is this, then the derivative of this point must be equals to 0. Let us say एक function एक ऐसा भी हो सकता है कि यहाँ से ये start हो रहा है, ठीक है, यहाँ तक आ रहा है, फिर दोबारा यहाँ से स्टार्ट होकर इधर आ रहा है. सो आई डिवाइड, इस तरह के फंक्शंस को मैं डिवाइड करता हूँ दो सेटअप्स में. फर्स्ट इज दिस वन, दिस आर्क, ओके, एंड सेकंड इज दिस रीजन. तो यहाँ का जो होगा इट्स C1 point and derivative of C1 point equals to 0, and second will be C2 and derivative of C2 point must be equals to 0. So this is all about my Rolle's theorem, जिसमें हम एक इंटरवल लेते हैं. वो इंटरवल बेसिकली स्टार्टिंग एंड एंडिंग पॉइंट है, उसके दरमियान कोई भी पॉइंट लेके उसका डेरिवेटिव जब लेते हैं तो डेरिवेटिव मस्ट बी इक्वल्स टू 0. ओके, लेट्स स्टार्ट विद द क्वेश्चन. Using Rolle's theorem, for each of the following functions, verify that the function satisfies the criteria studied in Rolle's theorem and find all values C in a given interval, that find where f derivative equals to 0. So my first part is, let us say f of x equals to x square plus 2x. Our this that is my a and b point. Okay. So for this sense, first I have to apply f derivative of -2. That is first value in my function. My function is x square plus 2x. So x square, that is x is -2, and second x is also -2. So it is 4 minus 4, which is equals to 0. This means that function value at -2 equals to 0. Now second, f at, I have to find at 0. So f of 0 equals to uh, x0 plus 2 of 0, which will be equals to 0. So my at both points, my value equals to 0. So therefore, f satisfies the criteria of Rolle's theorem. We conclude that at least one value within this interval must having derivative which is equals to 0. So this function f derivative of x equals to 2x. Now I have to take the derivative. So f derivative of x will be, the derivative of this equation will be 2x plus 2. Okay, so this will be taking 2 common, 2 into x plus 1. This is f derivative of c. So f derivative of x. Okay, so at any point, so I have to take this point at f equals to when my value equals to c. So ये मेरे पास जनरल वैल्यू आ गई डेरिवेटिव की, एफ डेरिवेटिव. अब मैंने इसमें c की वैल्यू पुट करनी, बिकॉज अकॉर्डिंग टू रोलर्स थ्योरम माय डेरिवेटिव ऑफ c मस्ट बी इक्वल्स टू 0. So I have to take the f derivative of any point within this interval equals to this one. So 2x plus 1. So this x will be replaced because this is point c. So I have to replace this x with c. So it is c plus 1. Okay. So x is basically replaced. So यहाँ पे f derivative of c equals to 0. So this is 0 into 2c plus 1. Then this comes here. So it will be 0 0.2 equals to 0. So c plus 1 equals to 0, which is that c equals to -1. Okay. So this is the solution using Rolle's theorem. This is the part number, solution of part number 1. Hey. Okay, now we have to plot it. Again, at what value? At value equals to -2 and 0. My both values, my function value equals to 0. So this means that this is 0. My value is 0 here and also 0 here. And here it comes a value that is c equals to -1. So -1 will be my c value, which is basically within the range of 0 and -2. Okay. Now moving towards next part, that is f of x equals to x cube minus 4 of 4x with -2 and 2 interval. So as for the both value, as I know that my function value equals to, first I have to write my function value. My function value will be f of x equals to x cube minus 4 of x. So this is my function value. I have to put my both intervals, my interval is -2 and 2. When putting f of function value -2, so it will be -2 cube minus 4 of -2. So -2 cube will be 8 minus 8 plus 8, which will be equals to 0. Now for the second case, ff2 will be equals to 2 cube minus 4 of 2. So this will be 8 minus 8. My answer will be 0. Okay. So this says that my function value satisfies the criteria of Rolle's theorem. Now I have to differentiate the function value. So I have to differentiate it. So differentiate f of x equals to x cubed minus 4x. The derivative will be f derivative of x equals to 3x square minus 4. Now I have to take f derivative of c, so it will be 3c square minus 4. So here it is 0, 0 equals to 3c square minus 4. So 3c square equals to 4 and c square equals to 4 upon 3. Now taking the under root, it will be plus minus 2 upon under root 3. Okay, so this is the value of c. This means that my value is positive as well as negative. So c has two values. It will be 2 under upon under root 3 and minus 2 under root 3. So my first loop starts from as f negative of 0 and sorry, this is f negative 2. Intervals are negative 2 and 2. So it starts with negative 2 and ends at positive 2. Now there are two intervals. Two intervals mean that it has two values of c. So this will be my c1 and this will be my c2 respectively. So I have to take a value at 0. Let us say my value at 0 will be f of 0 equals to 0 minus 0. So it also will be 0. So I have to plot this value too. So there will be an increasing graph for this and decreasing for this one. Now, what is the value? So the value is x equals to plus pi, this 2 upon under root 3. So by plotting this value is basically this lies at approximately this one. Okay, so this is how we find. This is basically this point, negative 1 point something. Okay, because the value x2 divided by under root 3 will be greater than 1 and negative 1 respectively. This is how we find the values by using Rolle's theorem and a graph for this polynomial over the interval negative 2 and positive 2. Okay, now next is the mean value theorem and its meaning. So what do you know about mean value theorem? So as for mean value theorem is, Rolle's theorem is a special case of mean value theorem. Okay, so this is important regarding a MCQ. So Rolle's theorem is a special case of mean value theorem. In Rolle's theorem, we consider differentiable function defined on an interval a and b with function value f of a equals to f of b. Okay, the mean value theorem generalized Rolle's theorem by considering functions that do not necessarily have equal values. That I have to say it again that let us say a and b are my two intervals. तो हमने रोलेस थ्योरम में क्या पढ़ा है कि जो डेरिवेटिव ऑफ फंक्शन की वैल्यू ए पे जो है वो फंक्शन की वैल्यू बी पे होनी चाहिए, दैट इट मस्ट बी इक्वल्स टू 0. तो ये मेरे पास क्या है रोलेस थ्योरम में. बट इन मीन वैल्यू थ्योरम my function at a equal to 0, but it must not be equals to 0. It must have two possibilities. Okay, so it must have two possibilities. It will be greater than or it will not be greater than. Okay.